welcome back. So we are in the next lecture in power electronics. The topic that we are going to take is our discussion on bidirectional semiconductor devices. Those are basically the DIAC and the TRIAC. Let us see the outline. So we will first discuss how this DIAC and TRIAC are important and what are their advantage in terms of the bidirectional features for the power electronic devices in terms of thyristors. Then we will see in detail about the DIAC and the TRIAC. So DIAC stand for the diode, which are for the alternating current, and TRIAC means the triode for alternating current. We will see the firing circuits, especially for the combination of DIAC and TRIAC. What are the protection and practical considerations to be adopted, the applications, and we will conclude the summary with the comparison. So the DIAC and TRIAC are basically bidirectional devices. So in the previous few lectures, we discussed on thyristors. So thyristors are basically control device but unidirectional. So in order to make it bidirectional, we prefer DIACs and the TRIACs. So in AC power system, most of the time it is required that the device should conduct in both the direction. So the unidirectional devices, what we have discussed, the silicon control rectifier, they need to have complex arrangements for having the AC control. So we need basically the simple cost-effective AC power control solutions. So hence the bidirectional devices are required, and those are basically not met with the help of the ACR. Some of the key features of these devices are, so DIAC stands for the diode for alternating current. They are basically the voltage triggered switch. Whereas the TRIAC are the triode for alternating current, they are current controlled switch. So DIAC is voltage triggered and the TRIAC is current controlled. Both the devices are basically belong to the thyristor family of semiconductor switches, and they are commonly used together for AC phase control applications. So DIAC and TRIAC are used together whenever we require any type of AC phase control. And these devices are essential for the residential and industrial AC power control, where the DIAC and TRIAC are used in conjunction. So the definition of the DIAC is basically it is a two-terminal semiconductor device with having the bidirectional switching capability. It is known as bidirectional advanced diode, or otherwise the two-terminal AC switch also. Here the terminals will be two terminals, MT1 and MT2, where MT1 means main terminal 1 and MT2 is main terminal 2. Sometimes these are also termed as anode 1 and anode 2. So the DIAC are two terminal and they are bidirectional device with the terminals named as MT1 and MT2. The characteristics is they don't have any gate terminal because it is voltage control only, and it exhibit negative resistance in the conduction region. It has the symmetrical operation in both the directions, and the fixed breakover voltage cannot be controlled. So we will be having the breakover voltage which is fixed and that cannot be controlled. Let us see the construction and structure of DIAC. So the physical structure involves the PN structure, arrangement of semiconductor device. So here you can see the DIAC which is involving two terminal, that is MT1 and MT2, and the structure of these semiconductor is in two different forms involving the PN structure. So it has the symmetrical construction with interchangeable terminals. So these terminals MT1 and MT2 can be interchangeable and they conduct current in either direction. So when we see the symbol of DIAC, it is as if the two diodes are connected in anti-parallel. So we can conduct the diode in both the direction. These are fabricated using the semiconductor technology. The working principle, again, it works as bidirectional avalanche diode and switches from the off state to on state whenever the breakover voltage is reached. So the VI characteristic of this DIAC having the operating regions which are having the blocking state when the voltage magnitude is less than the breakover voltage, and there will be only leakage current flowing. So in the conduction state, when the voltage application is greater than the breakover voltage, then the device will conduct with very low resistance. In the negative resistance feature it has because the current will increase while the voltage decrease during the switching phenomena. So this is the VI characteristic of a diode, which is similar to the original Thyristor, with a small difference is that it will be conducting in both the direction, and its operation is in quadrant 1 and quadrant 3. So you will be having the operation usually in the quadrant 1 and quadrant 3, because quadrant 2 is where you have the leakage current flowing and there is no conduction as such. Now the key parameters here is basically the breakover voltage, which is typically around 30 volt, and the voltage drop will be there during the conduction about 3 volt. The current limiting features, it is amplitude will be limited by certain external resistance that is connected in the circuit. So let us see the switching mechanism of this DIAC. So when we talk about the turn on process, we apply the voltage which is increased across the DIAC terminal, and if the voltage is greater than the breakover voltage, there will be avalanche breakdown occurring and the device will be switches to low impedance state, and that is a case of a negative resistance. The current amplitude is limited by certain external resistance which is connected to the circuit. In the turn off process, the device will be turned off when a current drop below the holding current. So this is what we have discussed for the thyristors also, that if we need to turn off the thyristor or any DIAC, then the current has to fall below the holding current. No gate control is available in this device as we have in SCR, because this is a purely voltage and current dependent. It has a natural turn off process at current 0 crossing in AC circuit. So we don't have a gate here similar to SCR, and whenever we need to turn off, the natural turn off process has to take place where the current will be crossing the 0 line in the AC circuit. Some of the important note, let us see, the DIAC is basically fixed switching characteristic device and it cannot be controlled once the breakover voltage is reached. Firing angle is fixed for a given supply voltage. So these are some of the important features of DIAC. And the circuit operation we can see for a DIAC. So here we have a DIAC which is represented with two diodes which are connected anti-parallel, and there is a supply voltage which is AC, and you can see there is a resistor which is connected externally which will be helping to control the current. So these are the two terminals, MT1 and MT2. So basic diode circuit operation, when we talk about, then the diode will turn on when the supply voltage will reach the breakover voltage, and in the positive half cycle the diode will be conducting because the voltage is greater than the breakover voltage, and in the negative half cycle of the AC supply the voltage is less than the negative of the breakover voltage. So there is a fixed firing angle based on this breakover voltage and supply voltage. So here we are giving the AC voltage to the DIAC, and the load resistor is basically controlling the excess amount of the current if it flows. So this is our output voltage with respect to time t, where the diode will be conducting at particular t1 time, and it will be conducted up to pi for the first half cycle, and the second half cycle again it will be conducting from t2 to 2 pi. The application of this diode is basically, it is primarily used as triggering device for TRIAC. It means the TRIAC is using this DIAC as triggering device. So that is the most primarily application of this DIAC. It is a two-terminal AC switch applications and used in oscillator circuit and simple AC controlled circuits. So general DIAC application will be only when it is accompanied with the TRIAC and for the triggering purpose. Otherwise it can be used for oscillator or the AC control applications. Now having known the DIAC, let us move to the TRIAC. So TRIAC is basically 3-terminal and not 2-terminal like the DIAC. Again, it is a semiconductor device and it will be having both bidirectional AC control, and it is equivalent to two SCRs which are connected anti-parallel, so similar to the DIAC, with having a common gate. So remember, in DIAC we don't have the gate, but here we have the gate which is common between the two SCRs, and it enables the variable power control in the AC circuits, can handle both direction of current flow. So in the TRIAC, one important feature is that this will be 3-terminal device now, not 2-terminal. And here also you can control the direction of the current in both the directions, similar to the diode. So what is the advantage over the silicon control rectifier or the thyristor? So it is a single device instead of 2 anti-parallel silicon control rectifier or SCRs. So the device is only one. The internal connections that we have is basically as if the 2 diodes are connected anti-parallel. So it is simplified gate drive circuitry is there, and there are reduced component count and the cost, and we have a better thermal management with respect to the SCR. Now the terminal, if we see, since it is a 3-terminal device, so we'll have MT1, MT2, and the third terminal will be the gate. So MT1 is the main terminal, this is the reference terminal, whereas MT2 is again the main terminal, and the gate is the control terminal which is present near to main terminal 1. So here we see the structure of the TRIAC. So here you can see 3 terminals are there, MT1, MT2, and the gate, where the gate will be located close to MT1, and the 2 terminals MT1 and MT2 are the main terminals. So this is the circuit symbol of the TRIAC. So it is similar to the DIAC with having 2 diodes which are connected anti-parallel, or the SCR connected anti-parallel, and you have a gate which is common between the 2 thyristors. So the internal structure is complex, having the semiconductor structure. It has a multiple current path which will be enabling the bidirectional conduction, and the gate will be located near the main terminal 1 for the control purpose, and asymmetric structure lead to different sensitivities. So you can see the structure is not symmetrical, its structure is asymmetrical, so it may be leading to different sensitivity of the device. The operating principle, if we see, it works like as if the 2 SCRs are sharing a common gate, and the gate is basically the current triggers the device based on MT2 polarity. So what is the polarity of MT2? Based on that, this gate will be triggering. Once it is triggered, the gate loses its control, the latching behavior, and the device turns off and natural current 0 crossing. So gate is used only to turn on, and once the device is turned on, you don't need the gate. And whenever we need to device to turn off, it is the natural commutation process. So we had discussed the different commutation process. Among that, it is the natural commutation process by which the device will be turned off. Now here we see the VI characteristic of the TRIAC. So in the TRIAC, we have the first quadrant where the MT2 terminal is positive with respect to MT1, and in the third quadrant MT2 is negative with respect to MT1, and this can be triggered with or without gate signal. There are multiple characteristic curve for different gate current. So if you can see that TRIAC VI curve, due to the gate which can have a different signal, you can have a different triggering points, and in the quadrant 1 and the quadrant 3 where your main operations are going on, where the terminals are positive with respect to the other terminal. So some of the characteristic features, if we talk about, then the breakover voltage will decrease with increasing gate current. So when you increase the gate current, the breakover voltage will be decreased. Forward voltage drop during the conduction is very small, and the gate control allows a variable firing angle. So it is the gate which is being controlled the firing angle of the thyristors and the triggering. Current generally rating are in the range of 1 ampere to 300 ampere, and voltage rating may go up to 1200 volt. So these are TRIAC specifications. So if we see the 4 mode of TRIAC operation and its sensitivity, so these are the 4 modes, 1 to 4, where the main terminal 2 is positive with respect to the gate. So gate and MT2 both are positive, when then it is the most sensitive. If the MT2 is positive and the gate is negative, then this is less sensitive. Both are negative, so more sensitive. And if MT2 is negative with respect to positive gate, then it is least sensitive. So if you see the most sensitive part, so it is when both are positive, and quite sensitive when both are negative. Otherwise, one is positive, other is negative, you will have less sensitive. So practical consideration, if we talk about, then modes 1 and 3 are predominantly in used. So we have the mode 1 and mode 3, which are basically in use because they have higher sensitivity, and mode 2 and mode 4 are less commonly used because they are less sensitive. Gate current requirement varies with the operating mode. So whenever the operating mode change, the gate current, whatever is need for triggering will change. The commercial TRIAC optimize for efficient operation. So there are many commercial TRIACs available which are basically optimized for having the efficient operation. Now here we see the operating mode of the TRIAC, which is generally in mode 1 and mode 3. So mode 1 where MT2 is positive and gate is also positive, MT3, MT2 negative and gate negative will go for the mode 3. Let us discuss the mode 1 first. So mode 1 is most sensitive mode of operation and the gate current flows from the gate to main terminal 1. Structure will operate similar to the normal SCR and the minimum gate current is required for the triggering. So we require very minimum current here when we need to do the triggering, and this is very sensitive. When we talk about the mode 3 where the MT2 is negative and gate is negative, it is the second most sensitive mode after mode 1, and here you remote gate effect is there through auxiliary structure. Slightly higher gate current is there needed for from the mode 1. So here you can see minimum gate current is required, you require slightly higher gate current here. Good sensitivity is there for practical applications. So we can say that mode 1 and mode 3 both are generally used. Less used modes are mode 2 and mode 4 where one terminal is positive and the gate is negative and vice versa, though these are less sensitive and they are rarely being used. So when we have the TRIAC and DIAC combination, we can have the phase control circuit, and in this case we required certain components for this combination of DIAC TRIAC firing circuit. Here we have, so here you can see this is a DIAC and this is a TRIAC. So the gate is being controlled and so many registers are there. You can say R1, R2, R3 and capacitor is connected. So R1 is basically the fixed register which is used for the protection purpose. R2 is variable register which is used for firing angle control, and C is basically the timing capacitor. The register R3 is gate current limiting register because you can control the gate current with the help of this register R3. Control principle, the capacitor will be charging through the sum of the register R1 and R2. So here you have R1 and R2 and the capacitor will be charging through these registers, and when the capacitor voltage become equal to the DIAC breakover voltage, the DIAC will start conducting. The capacitor discharges through the DIAC and TRIAC gate, and TRIAC will turn on and conduct until the current reaches 0. So here you will be TRIAC will be having the commutation. So when it is current is 0. If we talk about the control range, then the practical firing angle generally lies between the 10 degree to 170 degree, and variable resistance R2 is controlling the charging time, and thus you can vary the firing angle. Circuit operation, if we talk about, then the step-by-step operation, if we see the charging phase where the capacitor is charging through the resistors R1 plus R2, and the trigger point where the voltage is equal to the breakover voltage of DIAC, then the DIAC will conduct, and the gate pulse is basically capacitor which is rapidly discharges through the DIAC to TRIAC gate, and the TRIAC conduction take place when the TRIAC turns on and conduct until its current is 0, and then again reset process. The process will be repeating for the next half cycle. So these are the step-by-step operation of the firing circuit of DIAC TRIAC combination. Resistance control, if we talk about, then there are two registers value for R2, one is small and that is large. So if the register R2 is small, then you can have fast charging and you can have early firing and then high power output. Whereas the register, if it's large, then you can have slow charging and the firing will be late. So you will have low power output. Charging time constant, again this is a RC network. So the time constant tau is R1 plus R2, which is the R equivalent multiplied with C. So this is your R equivalent, which is summation of the two register multiplied with the capacitor value. So here we can see the waveform for different control settings when the register is having the minimum value and the register is having the maximum value. So both registers are basically have different firing angle and different control of the features involved with the TRIAC operation. When we talk about the firing circuit waveform, if we have the minimum R2, then we have early firing. If we have maximum R2, then we have the late firing. So let us talk about when the register value is minimum, then the capacitor will be charging quickly and the DIAC will fire nearly in the half cycle. The TRIAC will conduct for longer duration and there will be higher power which is delivered to the load. But when the register is maximum, then you will have late firing. Capacitor will charge very slowly, DIAC fire late in the half cycle, TRIAC will conduct for a very shorter duration and lower power will be delivered to the load. So it's better like we have with the minimum R2. So there is a waveform asymmetry issue. So the basic circuit will produce a unsymmetrical waveform due to TRIAC characteristic and capacitor hysteresis effect. Capacitor will retain some charge when input voltage will become 0 and additional component is needed for the symmetrical operation. So whenever we try to make the operation to be symmetrical, some more additionally components had to be added in the circuit. So this is the improved firing circuit for the TRIAC. So as we saw that is unsymmetrical, so let us add certain more components. And what was the problem with the basic circuit? That this is asymmetrical triggering was there due to capacitor hysteresis effect, and different positive and negative half cycle behavior was seen. Unequal power delivery was there in both the half cycle. So we can have the improved TRIAC control circuit with more number of components. So additionally, we connect R3 and C1, which will provide symmetrical discharge path. And there is a snubber circuit. Now this snubber circuit is basically the RC network which is used for protection during the voltage spike. And better waveform symmetry we can get because equal conduction will take place in both the half cycle. Commercial circuit will also include EMI filters and protection elements. So the TRIAC can be optimized depending upon the need. Now the protection is very important for TRIAC, and snubber circuit is one of the most famous type of protection we have already discussed in the previous lectures. So basically this purpose is to limit the dV by dt to prevent the false triggering in case of the TRIAC and or the other SCR devices. The component involving is the RC network, which is small across the TRIAC. So if you see the TRIAC here and DIAC here, so you are basically having the snubber circuit in terms of the RC network. So this is the protection purpose we are using for dV by dt protection. Otherwise, you can have the false triggering. So the additional protection scheme, you can connect the fuses, snubber circuit, EMI suppression can be there, thermal management. So these all are additional to the normal protection, whatever is available for TRIAC. You can have different type of protection, whether we talk about the overcurrent protection or when there is a dV by dt voltage spike, we can use the filters to reduce the electromagnetic interference. The thermal management or the heat sink are used for high power application because the current will be high. Some of the applications of DIAC TRIAC circuits, it is used in residential application, industrial applications. Residential applications involves the light dimmers, fan speed controllers, heating control, motor control. So here lot of residential applications we use it. In industrial applications we use as a temperature controllers, motor soft starters, static AC switches and heat control systems. Load compatibility if we talk about, then the resistive loads which have the excellent performance in heaters and lamps. Inductive loads require snubber circuit, generally motors and transformers, and universal motors are having good performance for the speed control. So DIAC TRIAC combination firing circuit are generally used for a lot of applications in residential and industrial, and this is the device comparison for the DIAC and the TRIAC. So the number of terminals if we take, then 2 is the number of terminal for DIAC, which is main terminal 1 and main terminal 2. In TRIAC you have 3 terminals, so you have gate extra in TRIAC apart from the main terminals. Here the voltage triggered is only used as the control method for DIAC. In TRIAC you use gate control technique. Triggering is done which is fixed, having the breakover voltage approximately 30 volt, but in TRIAC you have variable triggering with the help of gate signal. Power handling is low in DIAC but high in TRIAC. The primary function of DIAC is basically to trigger the pulse generation, whereas TRIAC is used for AC power control. And when we turn off the DIAC, it is generally to control the current below the holding value, and when the current of TRIAC reaches the zero crossing, it can have the commutation. Application of DIAC is basically for TRIAC triggering, and TRIAC is used for motor control, heating, lighting, etc. Voltage rating may be for DIAC approximately 30 volt, and TRIAC can go up to 1200 volt. Current rating of DIAC is few hundred milliampere, and it can go up to 300 ampere for the TRIAC. So we have learned few concepts related to DIAC characteristic, TRIAC characteristic, what are the circuit design considerations. So DIAC is basically two terminal bidirectional avalanche diode. It has a fixed breakover voltage around 30 volt, primarily used for triggering the TRIACs. No control can be done over the switching because it is the breakover voltage which is controlling. TRIAC characteristic is basically three terminal, which is again bidirectional. Gate is there to control the switching. 4 operating modes are there with different sensitivities and widely used for AC power control applications. Circuit design, we have discussed that DIAC TRIAC combination provides simple AC control. Protection circuit is essential for reliable operation. Asymmetry issues are there. With careful circuit design, we can avoid that. Snubber circuits are used generally for the inductive load for protection purpose. So here we complete our discussion on DIAC and TRIAC. Two important Thyristor devices. Apart from that, we have also discussed the commutation and the firing circuits, how it functions in the previous two lectures. We'll continue our discussion on power electronics. Thank you for now.